Okay, we're going to solve a 3x3 system of equations, which means that we have 3 variables. If you have 3 variables, you need 3 equations to be able to solve. So make sure that you have a calculator handy and that you try this as we go. There are some larger numbers here. So when you choose a variable to eliminate, it's your choice. You can choose whatever variable you want to eliminate. So you can choose to eliminate the x's by multiplying this by -3, and then again by -5 to eliminate here. But remember that when you choose a variable to eliminate, choose a variable that you can eliminate twice. And what we mean by that is that I see 2 different ways to eliminate it. So let's choose that we're going to eliminate x. And the first time, I'm going to multiply this equation by -3 using equation 1 and equation 2. So now we have 3x minus 5y plus 2z equals -53. And then the second equation will be -3x plus 21y plus 12z equals 111. And when we add these together, the x's cancel, and we're left over with 16y plus 14z equals 58. Okay, and from your steps, they tell us to name this equation A. Okay, so now we're going to do the same process with a different set of equations. Again, whichever ones you want to choose. There's a lot of choice in these type of problems, so you can pick which one you want to use. So we did the first one and the second one. Now maybe we'll do the second one and the third one. So we'll choose the second one and the third one by multiplying by -5 here. So my new equations are -5x plus 35y plus 20z equals 185. And then the second one we're going to choose as the third equation. And again, notice that both times I eliminated x. So if you're stuck on your problem that you're trying at home and you're not eliminating the same variable, that would be why it's not working. Okay, so we're going to... Okay, sorry, Miss Alvarez keeps calling me. So we're going to add our 2 equations together, and the x's cancel, and we end up with 44y plus 22z equals 242. Okay, so with those 2 equations, now I have equation A, and this will be called equation B. And with those 2 equations, both of those have a y and they both have a z. So this brings us to exactly like you did previously with systems of equations, where we have 2 equations with 2 variables and we can solve. Remember, however many equations or however many variables you have, that's how many equations that you need. Okay, so we can't multiply 16 by anything to get to 44, and we can't multiply 22 by anything to get to 242. So you might want to, you have many options here. You might want to multiply this by -44 and this by -6 or +16. Okay, either one can be negative. There are many other simpler ways to do this. So you could divide the equations all by 2 and try to simplify, but I'm not going to go into that because it's a little complex. You can actually divide the bottom equation by 11 and it'll make it a little more simple. So maybe I'll do it this way and then I'll do it the other way as well. So here you're obviously going to get really big numbers. and that's okay. But if you're not into that, just know that there is another way. So let's do it this way first, and we get negative 704 minus y minus 616z equals negative 22,552. And then on the bottom, positive 704y plus 352z equals 3,872. Okay, and when we add these together, the y's cancel, and we get negative 264z equals 1320. Okay, and then finally divide by negative 264 on both sides. And you get that z equals negative 5. And like I told you in class, once you get that number, everything kind of falls into place now. We work our way down to one variable, and we bring it back up and plug it into one of the two variable equations. I'm going to choose this one, 16y plus 14 times z equals 58. Okay, so we'll simplify 16y minus 70 equals 58. Add 70 to both sides, which gives you 140. No, I don't know where I got that from. It should give you 128. And then divide by 16 on both sides, which you should get 8. Okay, now that I have two variables, I'm going to go back up and take both of these and plug them into a 3 variable equation. So just to make this easier, I'm going to choose the middle equation, x minus 7 times y, which is 8, minus 4 times z, which is negative 5, equals negative 37. So we get x minus 56 plus 20 is negative 37, which is x minus 36 is negative 37, so x is negative 1. And we write these in alphabetical order, negative 1, 8, negative 5, x, y, and z. And that's your solution. Okay, you could always plug x, y, and z back into every single one of these equations and make sure that it makes a true statement, okay? And make sure that if you're starting from the beginning, that you eliminate the same exact variable both times.